Part A, using the identity cos A plus B is equal to cos A cos B minus sin A sin B, prove that cos 2A is equal to 1 minus 2 sine squared A. So all I'm going to do here is, instead of the B, I'm going to put an A. So I will have cos of A plus A is equal to cos of A minus sine of A sine of A. Simplifying that, A plus A is 2A. Cos A times cos A is cos squared A. Sin A times sin A is sin squared A. All I'm going to do now, notice that I want to have this only in terms of sine. I don't want to have a cos squared there. But that is fine because I know I can replace cos squared with 1 minus sine squared. And then the 1 minus sine squared A minus sine squared A is minus 2 sine squared A. And that's what we needed to show for part A of this question. Part B. Show that 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3 is equal to all of that on the right hand side. Now, let's notice that I don't have any double angles on the right-hand side. They're all sine theta or cos theta. There's no cos 2 theta there, there's no sine 2 theta there. So I need to deal with these double angles here, which is fine. I know what sine 2 theta equals. So I've got 2 lots of sine 2 theta. So 2 lots of 2 sine theta cos theta. I know that sine 2 theta is the same as 2 sine theta cos theta. Next, we've got minus 3 lots of the cos 2 theta. Now, remember there are 3 different versions of the cos double angle, but they've given us a hint in part A. They've told us to use the 1 minus sine squared A. So that's what I'm going to use. So 1 minus 2 sine squared A. Except in this case, it's obviously theta. Then I've still got the minus 3 sine theta plus 3 on the end. Right, let's expand these brackets and simplify as much as possible. So 2 times 2 sine theta cos theta is 4 sine theta cos theta. The minus 3 times the 1 is minus 3. The minus 3 times the minus 2 sine squared is going to be positive 6 sine squared theta. Then we've still got the minus 3 sine theta and we've still got the plus theta on the end. Now I notice that I've got a minus 3 and a plus 3, so they're going to cancel out to leave me with 4 sine theta cos theta plus 6 sine squared theta minus 3 sine theta. And then I notice that I've got a sine theta here, a sine theta inside this squared here, and another sine theta over there. So I can factorise sine theta outside of this to leave me with 4 cos theta plus 6 sine theta minus 3 on the inside. And that's what I needed to show for part B. Right, part C. We need to express 4 cos theta plus 6 sine theta in the form r sine theta plus alpha. So first let me write out the formula for sine A plus B, because that's what we're going to be using for this. This is in your formula booklet. So in this case, I'm going to be using my theta as A and alpha will be B. Also note that I'm timesing by R at the front there. So I'll times by R here, and I'll have to times the right hand side by R as well. Now, it's the 4 cos theta plus 6 sine theta that I'm trying to rewrite here. So let's compare these. I have got a cos theta here. I've got a cos theta here. So that must mean that this 4 is going to have to be the same as the r sine alpha. Now looking at the second term here, we've got a sine theta here and a sine theta here, which is going to have to mean that this 6 here is going to have to equal the r cos alpha. Now let me divide both sides by r to get my trigonometric ratios in a simple form, so that I can draw a little right angled triangle so I can figure out what r and alpha need to be. So sine is my opposite over the hypotenuse, so the opposite side here is going to be 4, the hypotenuse is going to be r. Cos is the adjacent divided by the hypotenuse, so my adjacent side here is 6. I can now do some Pythagoras. R squared is equal to 6 squared plus 4 squared. So r is equal to root of 52, I think. 36 plus 16. Yeah, 52. Root 52. Or we can write that as 2 root 13. I can also work out alpha by doing tan alpha will be my opposite, which is the 4, divided by the adjacent, which is 6. Do tan inverse of that. So tan inverse 4 divided by 6 is in, make sure we're in radians here. We know we're in radians because the alpha being needing to be between 0 and pi over 2. We get 0.588. So this has allowed me to rewrite the 4 cos theta plus 6 sine theta as 2 root 13 sine of theta plus 0.588. That is part C of the question done. So we just rewrote this as being 2 root 13 sine theta plus 0.588. Right, part D. Hence, for theta between 0 and pi, solve the equation 2 sine 2 theta equals 3 cos 2 theta plus sine theta minus 1, giving the answers in radians through 3 significant figures where appropriate. Well, it says hence. So this has got to have something to do with everything we've done previously. And it does look familiar. I can see I've got a sine 2 theta here. I've got a sine 2 theta there. I've got causes. It kind of looks the same, but it's not quite. What I'm going to do, I'm going to expand these brackets and move everything over to one side to see if it does look like this. So let's expand those brackets first. I'm going to get 3 cos 2 theta plus 3 sine theta minus 3. And then I'm going to move everything over to the right-hand side. So there's 2 sine 2 theta doesn't move. The 3 cos 2 theta, I'm subtracting that. I'm subtracting the 3 sine theta, and I'm adding the 3. Right, now I've rearranged that. Let's compare that again. Is this the same as what I've done before? Yeah, it is. It's identical, in fact. I don't need to do any adjustments. So that's useful because that means I can rewrite this with this because I showed that they were the same in part B. So I can rewrite this equation as being sine theta multiplied by the 4 cos theta plus 6 sine theta minus 3 equals 0. Now that's helpful because that tells me that either the sine theta has to equal 0 or the 4 cos theta plus 6 sine theta minus 3 has to equal 0. So if sine theta equals 0, then I know that theta is either going to be 0 or pi or 2 pi and 3 pi and so on and so on and so on. But 0 is the only answer between 0 and pi. Pi is not included. So that's one solution. The other solutions are going to come from this. So let's rewrite that part. So 4 cos theta plus 6 sine theta minus 3 is equal to 0. Well, let's note what we did in part C of the question. We rewrote this as this in part C of the question. So I can swap that here. Whilst I'm at it, I'm also going to add the 3 to both sides of this equation. Next step, I'm going to divide by the 2 root 13. I'm then going to do sine inverse of both sides. So let's do that then. So sine inverse of 3 over 2 root 13. And I find that that is either going to be 0.42906 or... right, I need to draw a sine graph to find out what else this could be. So my sine graph, here's pi over 2, here's pi, 3 pi over 2, 2 pi. So it is looking like this. I have one solution here, which my calculator has already given me, which is the 0.429. There would be another solution here, which would be at the pi take away 0.429. So let's do that. Pi take away that, which would be 2.713. And those are the only two solutions that are going to end up being between the range of 0 and pi, I think, maybe. Because my final step is going to be, well, actually, in fact, we need to subtract this 0.588 away from both of them. Which is fine for the subtracting that away from the 2.713. That is fine, no problem there. That's going to give 2.12 radians. If I try to subtract that off here, however, that's going to be negative. If I do 0.429, take away 0.588, that is negative. It's going to be outside of the range. So that is not going to be one of my answers. So my only answers are 0 or 2.12 radians. And we're done.